Okay, area scale factor. So if we're given a rectangle, in this case it is a 2 by 3 rectangle, and we want to increase that rectangle by a factor of 2, well, we want to increase each side by a factor of 2. So this side, 2, will be increased by a factor of 2, so we just times it by 2. So we're going to have a side now of 4. This side, 3, will be increased by a factor of 2, so this side will be 6. So we'll have a rectangle now that is 4 by 6. So we can say now that the length of the sides have increased by a factor of 2. But what about the area? Because the area for the original square will be 2 by 3, which will be 6. But the area for the new one is 4 by 6, so it will be 24. So the area hasn't increased by a factor of 2. It's actually increased by a factor of 4, because 6 in the original one multiplied by 4 gives you 24, which is the area of the increased rectangle. So how do we work this out? Well, we can go back and say that the lengths of the sides has increased by a factor of 2, but the area, where should I write this? The area has increased by a factor of 2 squared, which equals 4. Factor of 2, we always square it, and it's increased by a factor of 4, because 4 of the original shapes will fit in to the new shape. 1, 2, 3, 4. Okay, now if we want to increase by a factor of 3, we do the same thing for the sides, multiply that by 3, so 2 times 3 will be 6, 2, 4, 6, and 3 times 3 will be 9, so 3, 6, 9. So there's my new rectangle. It is 6 by 9. So the lengths have increased by a factor of 3, but the area has increased by a factor of 3 squared, which equals 9. So the area is 9 times larger than the original with a factor of 3. And to prove that, the original shape should fit into the new shape 9 times. So let's have a look. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9.